Well, we're going to talk about Lami theorem. It can also be called as sine rule. And you can use Lami theorem to solve tension questions. Let's say if there are three strings and three forces are applied on a point as T1, T2 and T3. Let's say the angle in front of T1 is equal to alpha. Angle right opposite to T2, let's say, is beta, and let's say the angle right opposite to T3 is equal to theta. Then according to sine rule, you can say that T1 divided by the sine of the angle right opposite to T1, which is sine of alpha, will be equal to T2, which is tension, divided by the sine of the angle right opposite to T2, which is sine of beta. And that will also be equal to tension 3 divided by the sine of the angle right opposite to T3, which is sine of theta. So this theorem allows us to solve questions quite easily, actually, without finding the components of the tension. Let me put a question on the board and solve the question using this Lami theorem. Let's say there is a wall over here, there is a string attached, and the angle between the string and the horizontal is 10 degrees. There is another string over here which is also attached to a wall, which is making an angle with the wall, with the horizontal. Let's say this is 5 degrees. And let's say there is a mass attached here, and this mass is equal to 65.0 kilograms. Now, using Lami theorem, find tension 1. This is the tension 1, and this is tension 2. All we need to do is to find, first of all, the tension in the string, which will be equal to the weight, because this is in equilibrium, therefore the tension has to be equal to the weight. So let's say this is tension 3, which is equal to mg, and that is 65.0 multiplied by 9.81, and using three significant figures, 65 times 9.81 is going to give you 638. So let me just put the tensions and the angles so that it's going to give us quite an easy picture. We've got T1 over here, we've got T2 over there, we have got 638 newtons over here. Now I need to find the angles first of all. If you look at here, we have got 10 degrees over here and the right angle there, 5 degrees over here, and 90 degrees there. So this is going to be 90 plus 5, which is 95, and this is going to be 90 plus 10, which is going to be 100 degrees. So what is left? If you subtract 360 minus 195, then you are going to get the angle in the right opposite to 638. Which is 165. So this is 165 degrees. I'm going to write down the Lami theorem here right now. T1 divided by the sine of this angle, which is sine of 95, will be equal to T2 divided by sine of this angle, which is sine of 100, which will be equal to, the force applied here is 638, divided by sine of the angle right opposite to there is 165. So this is a given number, so using this number you can find T1 and T2. So T1 simply will be equal to 638 divided by sine of 165 multiplied by sine of 95, which will be, let's find this one as well using a calculator. Sine of 95 divided by sine of 165. So that is going to give you, in three significant figures, 2,460 newtons. Similarly, you can also find T2. T2 will be equal to 638 divided by sine of 165 multiplied by sine of 100, which you can also find. In three significant figures, this is going to be 2,430 newtons. So as you can see, we didn't even have to find the components of any of those forces using this Lami theorem. You just write one line equation. By using this equation, you can find T1 and T2. If the question asks you, for instance, if the rope can exert a maximum tension of 3,500 newtons, what would be the maximum mass of what would be the maximum mass that can be suspended? So the maximum tension in any of those ropes is going to be T max will be 3,500 newtons. So if you have to decide which one is going to be 3,500, because you cannot say both of them will be the same, because both of them will not be the same. If both of them are the same, then this equation cannot be satisfied. So you have to identify which one to choose. If you look at our solutions in the previous part, we have found that T1 is greater than T2. Therefore, if you choose T1 as 3,500, then T2 will be less than that. Whereas, according to again this equation, if you think that T2 is 3,500, then T1 has to be greater than that, and that in that case the rope is going to break, because the maximum tension that the rope can hold is 3,500. Therefore, I can immediately say T1 will be 3,500. So I'm going to write it down as T1 has to be 3,500 newtons. So I'm using the same theorem over here. 3,500 newtons divided by sine of 95, angles stay the same, will be equal to T2 divided by sine of this angle, which I don't need. I am trying to find the maximum weight. In this case, the weight is not equal to 613. I'm trying to find the maximum weight. Therefore, I'm going to write this is the maximum weight divided by sine of this angle, which is 165. So cross this one, use this one to find the maximum weight. Maximum weight will be equal to 3,500 divided by sine of this angle multiplied by sine of 165, and then you will get maximum weight as a number. Okay, you find the number here. I'm not going to do it in here. You solve it, please. And then you will say weight is equal to mass times g. Therefore, insert this number over here. G is 9.81 to find the mass in kilograms. And that's going to be the easiest way to solve those sorts of questions in the future, maybe. Good luck.